Hello everyone, me again. Um, First and foremost, apologies for the weird long delays in my videos. I'm currently almost finished with my fourth semester in college here in Montreal, and I've been honestly speaking, I've been busy with work. If you realize already by this video, I'm not actually in my data center. I'm in my room. Uh, um, Today's video is going to be slightly different. I'm going to actually do a video now based on how to subnet, and just a fair warning, it's going to be very boring. There's nothing fun about this, but unfortunately, when you're in this kind of field and when you do this kind of work, you're going to actually have to know how to do this. And of course, some of you who are watching this video are gonna probably look at me like a complete fool or maniac or whatever, and just laugh at me because you do this probably on a daily basis and you do this off the top of your head. Well, I have one of my courses that I'm taking is a networking course, and it's an introduction to networking. And a lot of me and my friends and I, and a lot of them don't quite know how to subnet properly yet. They're gonna get there, but not just yet. And I have done it already now quite a bit, so I'm a little bit more comfortable, naturally. But anyhow, we're going to see today how to subnet a basic IPv4 or IP address, whatever you want to call it, so that we can apply it to a network or to a router or something. I'm going to actually show now on my whiteboard how to do this. So I'm going to switch my camera to my crappy whiteboard, and we're going to proceed with our problem. All right, guys, here we are. This, of course, if you couldn't tell already, is my nice little whiteboard that I have in my room. I am going to do a tour of my room, just like I did with my garage, my data center. But, of course, we'll keep it to the same topic, and we'll see. This is the boring stuff, unfortunately. The fun stuff is actually what's going on around in my room. But this is just the boring stuff. So, of course, I'm going to drag myself now for I don't know how long in this video and try to get some sense out of somebody. But if it doesn't make sense at all, just rewatch the video. Or maybe by the time you're rewatching the video, you'll be probably already asleep. So, it's alright. Do whatever you got to do. But, in the meantime, assuming that you're still awake and that you actually have both eyeballs on the screen over here, I actually have my little paper over here in front of me, so I'll be professor for today. I've done already this problem, just to make sure that whatever I'm about to say is not wrong, so I don't make a fool out of myself. So, anyhow, enough of the jokes. To get on with the problem, this is our problem. We have a network address with a custom subnet defined already, noted by the slash notation over here. And of course I didn't underline. 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 There we go. This video is not going to be perfect, but I don't care. That's our custom subnet. We have a custom network address that we're given, 165.200.0.0 in this case. And what we want to do is we want to find all of these scenarios or problems. Okay, so we want to find the custom subnet mask, the address class of this guy, the default subnet mask, the number of bits borrowed in your custom subnet mask, the total number of subnets, the total number of hosts, and the total number of assignable hosts. So of course, we'll just get into it. We already know what our custom subnet mask is because we are given it right here. This is our custom subnet mask. This, by the way, for those who don't know, is referred to as slash notation. And basically, this is a very small way to abbreviate the number that I'm about to write. And this number is going to be in the full, whatever form you want to call it. It's going to be 255.255.255. I think 192. Okay. Now, if you're really curious to see what's going on, and I will show it actually because it's going to be part of our little problem that we're going to solve. The /26, the number 26 refers to the number of leading zeros that are in your address. So for example, 255, if when you're going to see now when we expand this to binary form, because this of course is decimal form, you're going to see that the number 26 represents actually the number of ones that are in that subnet mask. Okay, but anyhow, until we get there, we're going to solve the rest. So we know our custom subnet mask is this. We want to find the address class. So based off of this, we can tell already that the address class is going to be a class B. You just look at the first portion, you don't even have to worry about the rest. You see that 165, if you look at the ranges for each of the address classes, that's going to fall under a class B category. So we're going to write that down. Class B. And the default subnet mask for this class, for this class, is going to be 255.255.0.0. Okay, and I can double check that. Yes, that is correct. The number of bits borrowed. So to find the number of bits borrowed, you have to look between your custom subnet mask and your default subnet mask. And for this, we are going to switch to binary notation because you're going to see why now in a minute. We want to count from this point onwards because the leading ones stops right about there. And if we mark it the same way here, you're going to see that usually it's going to stop there. But as you can see, it's not .0.0, it's .255.192. So to count the number of bits that we have borrowed in our custom subnet mask, we're going to take this number and we're going to convert it to, or at least, sorry, we're going to take this portion and we're going to convert it to binary notation. So this portion in binary notation is going to be 192, which I know already is going to be, okay, no, yeah, there you go. 192 is going to be 0, 0, 0, 0, 0, and then, oh, sorry, not 192. I'm so stupid. 255, of course that's not 255. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this 255, and of course if you don't believe me, you can do the conversion and you see it's going to come out to the same, and I can double check. Yes, it comes out to the same. 255 in binary is just, sorry if my light is blinding my board. 255 in binary is just 8 ones. Okay. And 192 in binary is just 11000000. And of course, for people who do not know what binary is, I would suggest to watch or look up how to convert and how to understand the binary system. But assuming, of course, if you watch this video, you already know what binary is, so I don't have to worry about that. So now if we look at between this binary representation, and we can even do this, but it's honestly speaking not necessary, but for visualization we'll do it anyways. This in binary is going to be nothing but a bunch of zeros. So to find the number of bits borrowed, and we already know that usually our subnet mask would stop for this address, stops there. But if you look here, if we mark it the same place, you'll see that it's not .0.0, it's .255.192. So we have more leading ones. So basically we want to count the extra number of leading ones that are in that address, that custom address. So if we count, and now it's just a matter of counting, we'll see that this is 8, 9, 10. So we have a total of 10 bits borrowed. So we'll write that down. 10 bits borrowed. So we just put even bits, doesn't matter. So again, very easy. We find out where the subnet mask, the default subnet mask, first you find that out, the default subnet mask. Then you find out where the number of leading ones stop. In this case, it's right at about the third octet. And if you look at our custom subnet mask, and if we put the same marking there, around at about the same place as this one, you'll see that once we go to binary form, you'll see these are all the number of leading ones that are borrowed or added on, if you want to call it. Okay, so, and again, once you do that, you just count 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you write down 10 bits. Now, to find out the total number of subnets is probably going to be very easy, as with the rest. This is probably the most work you're going to probably do. The total number of subnets is simply 2 to the power of the number of borrowed bits. So in this case, it's going to be 2 to the power of 10, which equals to 1024. Now, you might think 1024 is a big number, and of course you're not wrong, it is a big number, but in terms of networking, it's completely normal. If you actually look at the number of theoretical IPv4 addresses you can have, it's somewhere in the millions, right? Whereas IPv6 you can have up to billions, even over the number of people we have living on the planet of the Earth today. So these numbers are perfectly fine. So if you see numbers like, let's say, 8,000, 10,000, if you're following this way, you should be okay. All right, mind you also, there's also calculators out there on the web that show you, or not maybe show you, but calculate. You just put in the network address or the host address along with your subnet mask, your custom subnet mask, and it's going to spit out all of this information for you. But assuming this is something that you're just learning now and you're going to have a test or something, you cannot just go on the calculator and enter your numbers. So you actually have to work it out on a piece of paper or whatever, and then you can use, maybe if you're lucky, a calculator afterwards to double check your answers. This is the proof that you need to have. Anyhow, so the last two portions that we have are the total number of hosts and the total number of assignable hosts. Now, the difference between the two is that with the total number of hosts, this will include what's called the network address, or I should say in this case, the subnet address, and the subnet broadcast address. Okay? And in between those two addresses is going to be your total number of assignable hosts, or your range. So to find the total number of hosts, very easy once again, you have to do 2 to the power of the number of bits that you have left for the host. And remember, the number of bits left for the host are going to be your zeros in your custom subnet mask. Okay? So to count, we see here we have 6, 4, plus 2, 6, and the rest are not applicable to us for this portion of the question, or this part of the question. So we do 2 to the 6, which will be, of course, 64, and I'll write that down. 2 to the 6 equals 64. So this is the number of total number of hosts you can have per subnet. So for each of the 1024 subnets that you just calculated here above, each of those will have a total number of 64 hosts. Now, in reality, let's say you have you're actually doing a configuration, let's say on a Cisco router or home router, doesn't matter. What you'll have as an IP address for all your computers and devices is not going to be either your subnet address or your broadcast address. It's going to be anything in that range, in this range here, the assignable hosts. So to find that, it's very easy actually. I don't even have to look at my paper. It's going to be what you found here, minus 2. So 2 to the 6 minus 2. In this case, it's going to be 62. So the number of assignable hosts you can have per subnet, I should have put per subnet, is going to be 62. And the total number of hosts you can have per subnet is 64. And again, 64 because that includes the subnet address and the broadcast address. 62 refers to only the usable range. Okay? And again, the usable range is basically the IP addresses that you actually see on your, let's say, laptop, tablet, and not on, maybe the IP of the router is different. Okay? So, that's basically that. Let's see. The next thing we're going to do is we're actually going to take all of this information that we found out, and we're going to find out how to do how to find out the specs, if you want to call it, for a certain subnet. Okay, so what I'm going to do is I'm going to erase some of the stuff because unfortunately my board is not too big, so I cannot continue writing on this board. Alright, so here we are again. Now my table is, or my board is slightly rearranged. I erased what we have done now from before, and I rearranged it so we can solve now our second part of our whole subnetting process. So what we're going to do now is we're going to take what we did from before and apply it to this. So we're actually going to be in a normal situation. We're given the subnet range that we want to find the specs for. So in this case, we're asked to find the specs for the 10th subnet range. The reason why this is in parentheses and that I have a 9 outside representing the subnet number is because if we look at the bottom, the way in which we count the subnet numbers, we start at 0. So to find the 10th subnet range, if we count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we land on 9. Because the subnet number 9 represents the 10th subnet range. And again, why? Because we count from 0 and not from 1. If we counted from 1, then it would have been the actual number 10. But since we start from 0, okay, this is already predefined and it's already in place, so we cannot change it. So we count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we land on 9. And this is just basically a quick way of visualizing this, because at first glance you are going to be confused, but take a minute to absorb this and to look at this and you'll understand for all the other problems. So in general, if you wanted to find the proper subnet number, and you're going to see why this is all important in a second, it's going to be the number that you're given minus 1. So in this case, it's number 10. So minus 1, of course, is 9. So let's say if you're given the 1025th subnet, I don't know. It's going to be actually the 1024th that you're going to base these calculations off of. And again, why? Because you start from 0. You don't start from 1. Okay? So with that in mind, what we're going to do now is we're going to actually take these two numbers up here that we found, or at least that were from this we found, but this was given to us. We're going to take these numbers and these addresses and we're going to convert them into the, binary notation. You already saw this one, the last portion of it in binary, or we're going to put the whole thing in binary. So now, to do the network address in binary, and I'm going to double check my paper so I don't get this wrong. And again, this is just basic conversion from binary to decimal, decimal to binary. So if you don't know how to do that, I recommend either look up on YouTube, because there's 10,000 other videos explaining how to do it, or read it up, whatever you like. So anyhow, to convert 165 to binary, that's going to be 10, and my marker is not very good. I have to get new markers. I have to get a lot of new things, unfortunately. So that's going to be 10, 10, 10, 10, 0, 1, 0, 1 dot, yeah, 200, that's right. 1, 1, 1, 0, 0, 1, 0, 0, and then the rest is very easy because it's just 0 dot 0, 0, 0, 0, 0, 0, 0, 0. So this is the complete binary representation for our network address given from the get-go. Basically, and I can double check that to make sure that's correct. 0, 1, 0, 0, 1, 1, 1, 1000. Yes, that's correct. So now we want to convert this subnet mask into binary form. So again, and you're going to see why this is all important, and yeah, you're going to see why in a few minutes. So 255, of course, is very easy. It's just a bunch of ones. Dot 1, 1, 1, 1, 1, 1, 1, 1. That's 255, 255. We're missing another one. 1, 1, 1, 1, 1, 1, 1, 1. And that's 192, so that's going to be 0, 0, 0, 0, 0. Okay, so here we go. These are now our binary representations for these addresses. So this is our our network address. This over here in binary, and our custom subnet mask in binary. Okay, so what I'm going to do, the very first thing is I'm going to actually define or show where the number of borrowed bits are. So in this case, that's going to be right after the second octet. So that's going to be just right about there. The host bits are going to be all of these zeros, because again, the host bits, you can easily find them by looking at your custom subnet mask and looking at the zeros. Okay, so I'm going to write this down. Oh, hey, I have some space. So I'm going to say host bits. These are your host bits. Now, to find the number of borrowed bits, we look again back to what we found from before. We know that anything beyond here, excluding the zeros, are going to be your number of borrowed bits. So basically, it's just this. This second box now that I created. So now, if I put some arrows, host bits, and I put borrowed bits. So this box represents, for this portion of the address, the borrowed bits, and that portion of the addresses, the host bits. Okay? This is going to be important now. You'll see when we find this. So now what we want to do is we actually want to find out what the number 9 is in binary. And that's actually very easy. That's just going to be, of course, this is again basic conversion going from back and forth. The number 9 in binary is going to be 1001. 1001. Now, why do we want to know about, why do we give a hoot about this number? Well, to find the subnet address, you're going to take this number and you're going to place it within your network address where the number of hosts, not the number of hosts, sorry, the number of borrowed bits are, the position. So this 1001, I'm going to make some more space here. If we were to take that 1001 and place it in our address, our network address, I'm going to bend down a little bit because I got to get to the bottom of the board. So this 1001 in our network address, so I'm not going to write the whole thing because this will be the same. The only thing that will change is basically this ending. So if I write that here, that's going to be 0, 0, 0, 0, 0, 0, 1000. Actually, I can double check that as well. That's going to be, yeah, the same 0, so it's 0, 0, 0, 1, 0.0, yeah, 1, 0, and then the rest is going to be nothing but zeros. All right, so again, what I did was I took that 1001 that I found from converting the number 9 to binary, and I'm taking this number and I'm putting it in the network address where the number of borrowed bits are. So, and if I mark that here, my paper just fell to the floor. These are your host bits, and these are this, or I should say, this is the portion that represents the host bits. This is the portion that represents the number of borrowed bits. Okay, so again, I just took that 1001 and I placed it right at where I have my borrowed bits are. So now the only thing that we have to do really is we know that the first two portions are going to be 165.200. We just have to convert, and we know that, actually no, sorry, not the last portion. We just have to figure out what the last two octets are. And in this case, that's going to be .2. Actually, no, sorry, wait a minute. So double check. Yeah, sorry, I'm so stupid because I'm getting confused by my marker. It's .2.64. So again, we take this. We know that this in binary is, sorry, this in decimal is 2, and this is going to be 64 in decimal. So 2 to the 6 is 64, 2 to the 1 is 2, and we put it there because we know that the first two octets are not going to get touched. So our subnet address for the 10th subnet range is 165.200.2.64. Now what we're going to do is we're going to find the broadcast address because that's going to be pretty easy. Actually, it's going to be very easy. So to find the broadcast address for the 10th subnet range, we're just going to take the number of host bits in our network address and we're going to flip them to 1. So if we were to do that, I'm going to write the last two portions again. We're going to convert all of these 6 zeros into 1. So that's going to look like this. 4, and it's important actually also that we keep what we found here, the 1001, we have to keep that. We cannot change that. So that's going to look like this. 0.01, and the rest is going to be 1s. There we go. So as you can see, and again, this is just the marking to show where the number of bits are borrowed in my custom subnet mask, and the rest is predefined there. So the 1001 we keep, we do not actually put 0 because we'll get wrong answers. And you'll see that now all of our host bits have been converted to 1. So what's left to do now is just to take this and convert it into decimal. So that will be, this will stay the same. This will be 2.2, but this is going to be now 127. So our broadcast address for the 10th subnet range, and again, the 2 first octets stay the same, so that's going to be 165.2.127. So that's our broadcast address for the 10th subnet range. Now it's very easy to figure out our host range. Probably going to be easier than all of this mess. So to figure out that, we're just going to add 1 from here. So that's going to be 165.200.2.65 all the way to 165.200.2.126. I'm subtracting 1 here. And if you do the math, you'll see that this is going to be about 62 assignable hosts. Okay, so from here I added 1 because it cannot be 64 because this is the subnet address for the 10th subnet range, and this is never going to change, and this is never going to change for this subnet range. You can never change. Okay, once you find it, you don't touch it. Okay, and to find the end of the range, it's just going to be your broadcast address minus 1. So in this case, 127 minus 1 is 126. All right, and as you can see, it's a lot of information, and of course, if you don't understand, I would rewatch the video so that you can understand. This is probably longer than what you actually need to solve such a problem, but it's just to go a little bit in depth and to show how you do this properly, and hopefully that you can actually do it next time a little bit faster. I mean, I've gotten acquainted with it a little bit better now, knowing how to do subnetting, and also over the years, I've done quite a bit. Maybe not necessarily for IPv6, but I've done it for IPv4. But again, this is just to show you how to do subnetting for a simple IPv4 address. And again, also, this way is how I do it. I find that this is the best way, of course. But it doesn't necessarily mean if you have a better way of doing it. I mean, look, honestly speaking, just stick with that. Nobody's going to bug you about it. As long as you get the right answer, that's what matters. Okay? And also, again, in this case, we were given, if you look from back to the beginning, we were given only the network address with the custom subnet address given. We can be given a situation where we are given the network address, but we're given the number of, let's say, hosts that we want per subnet. And based on that information, you should be able to work around from what we know or what we've done here to find out whatever has been asked. Let's say they tell you find the broadcast address for the 10th subnet range or the 20th or whatever. These principles apply to all problems. If you can work your way around those problems, and if you can solve this problem, most importantly, then you should be able to do all those other problems. So I hope that video wasn't, or this video is not going to be too long. So I don't know, we'll see, because I'm just going to go on my phone. Because of course, for whatever reason, I'm still filming with my phone. I have yet to buy a camera, an actual professional camera. And that is a plan that's in the making. And hopefully I can film with maybe a slightly better camera and not just my iPhone 8 Plus, because that's what I have, is I'm using an iPhone 8 Plus to film all these videos. And hopefully I get a new camera. And of course, I'm going to do more videos once my semester is over about the data center in the garage, my garage. And of course, maybe I'm going to be doing a tour of my room. I'm not doing one right now because otherwise the video is going to get too long. It's probably going to be long already now. I have no clue. Anyways, I hope you liked the video. Please comment if you haven't. Please comment if you have any questions or just want to tell how bad I am at teaching over here in my room. Comment, subscribe, all that good stuff. You guys already probably know how to do that because everybody else out there on YouTube land already says that. So comment, subscribe, like, hit the bell, whatever. Hit the bell, go to class, or I don't know what the hell. Do whatever you want to do. Support the channel, and hopefully I can upload some more videos in the future. Until then, see you guys around. See you. Bye.